Okay, Lan, I have full control now, it looks like.
Yep.
So first of all, thank you so much to everybody for coming today. Appreciate it. We're very excited about this new part. It's the third device in our 51 series devices, which have proved to be extremely popular in the ANT field and the Bluetooth Low Energy field. And as we spoke about at the end of last year, and we held good to our promise, we would release a device this year which incorporated both those protocols in a single device. So our target, we made our deadline, and we released this device yesterday. So this is available now. It's the 51922, so it complements the 51822 Bluetooth Low Energy device that we've had out for quite some time, and the 51422 ANT device that we've also had out for the same length of time. So what I'm going to try and, the objectives I'm going to try and meet today are give you an introduction to the hardware and software features of this device, how it relates to the 51822 and the 51422. I think because it is containing both ANT and Bluetooth Low Energy, it's important that we look at what the benefits and the features are of those two protocols. They are both ultra-low power wireless protocols, there's no question about that, but there are some fundamental differences, and they really do complement each other very, very well. So I'll try and cover that and show you how this device can open up a lot of opportunities for a single chip solution in ultra-low power wireless. So we'll look at ANT and Bluetooth Low Energy essentials, and we'll also look at some of the use cases for the 51922 out there in the market. So let me just make sure. Yeah. Okay. So really, where does the 51922 fit? I'll go into some greater detail on application scenarios and use cases a little bit later, but just to cover really what ANT Plus is and what Bluetooth Low Energy is for people who are not very familiar. ANT has been around for, I think, 8 years now. It's proved to be extremely popular. We were the first company to work with Dynastream, who own the ANT IP, and it is their protocol that we put on our devices. Since its introduction to the market, there's over 50 million ANT-enabled products in the market. So that's a very considerable existing market of products that are out in the market. Now, ANT is the protocol itself. Where the plus comes in is the interoperability that is possible with ANT. So a very nice feature of ANT is that you have this ANT Plus feature, which means when you make a product, you can keep it completely private if you want, and it only will communicate with other products in your line. That's perfectly doable. But what you also have is this ability to make your product openly available to talk to other products. And you can control the level at which that takes place. So you can decide that your heart rate monitor or your light controller, whatever it is you make, you can choose what sort of functionality you open up to the world. So you can still make products, open them up to other products, but reserve some special features for yourself to bring added value to your products. So it's a very, very well thought out protocol, actually. I have to say, we really sit in 3 markets as a company. We're obviously very strong in Bluetooth Low Energy. We're dominant in ANT, of course, and we have 2.4 gigahertz proprietary solutions. It has to be said, in almost every scenario, ANT, byte for byte, is the most power efficient protocol out there. So really, if you look at transferring a certain amount of data over a certain amount of time, ANT will nearly always be the winner in terms of power consumption. So it's important to keep that in mind. If we move on to Bluetooth Low Energy, well, of course, there's been an awful lot of news about this, and I'm sure everybody's hearing about it. There's news everywhere. There's the Internet of Things, all sorts of related aspects to Bluetooth Low Energy. Also very, very efficient, a very lightweight protocol. very efficient in terms of power management. Again, easy to work with. It's not like classic Bluetooth. It's pretty simple to work with in terms of the API. The real shining star for Bluetooth Low Energy, it has to be said, is it's going into all the smartphones. Now, Ant is in some smartphones and some tablets. It just made it into the Samsung tablet. But Bluetooth Low Energy is present in every phone, really, that is coming off the production lines now, and has been in a lot of phones. It's been in the iPhone 4S and onwards. I can't remember where it started with Samsung, etc. But any Android phone, any iPhone, for some period of time now, is Bluetooth Low Energy enabled. Again, I'll look into a bit more detail there, but it's fairly obvious the benefits that yields. All of a sudden, you're connected to everything else in the world. So that's a very powerful aspect of Bluetooth Low Energy. So if we look at the highlights of this part, of course, I tried to outline why those two protocols are very good and where they're very good. So now you have a single system on chip that can handle both of these protocols. I think the key word here in the first point there is it's concurrent. It can handle them concurrently. So anyone who's worked with protocols will know you have to have them, but if they're not well thought out, they can be a pain. The beauty of this, and we've thought about it very, very deeply, is that we realize we can't be switching all the time between Bluetooth Low Energy and Ant in terms of turning protocol stacks on and off. You can do that in this device should you wish to, but we believe most use cases will involve both stacks to some degree being alive, being in communication, and they need to behave in a graceful way side by side. And that's what this device does. They can run concurrently side by side. So the stacks are pre-programmed into the device, so you don't have to load anything up. The device comes with the stack already programmed in. You've got a full low-energy Bluetooth peripheral stack, so that's peripheral and broadcaster roll. You've got the full 8-channel stack, so anyone who's got any familiarity with, say, the 24AP2 device, you've got all that functionality and some more. They've actually introduced some extra features into this protocol stack that we've put on board. As I say, fully concurrent, can run them side by side. And also a very, very critical feature, something that we were very insistent on when we embarked on the 51 series devices, was that they must be pin compatible with each other. We take great pride in listening to our customers and really speccing our chips according to what customers are asking for. And it was often said to us, there are different protocols, there are different wireless solutions out there, and it isn't always clear which direction I want to follow. So what we did with all of these devices is we made them with exactly the same pinouts and with an extremely flexible internal system, which meant you could route out as you need within these devices. So to put that in context, if you've already designed a product, laid it out for the 51422, or for that matter, the 51822, you can drop this chip straight onto that board. Now, of course, you will have added functionality, I would assume. That'd be the reason why you'd be migrating to this device, because you're either employing the Bluetooth Low Energy functionality, or you're employing the ANT Plus functionality. But from a hardware perspective, it means you don't have to start relaying out PCBs, etc. And that's a very, very important thing. It gives you an awful lot of flexibility. It means you can make your PCBs and not worry about having 100,000 PCBs in the factory that are not compatible with the chip that you've now migrated to. You can happily move between any of these devices. The other flip side of this, trying to make everything extremely compatible from a hardware and a software perspective, so that life is as easy as possible for developers. We've done it with the hardware, and we've also done it with the application code, which is essentially the API, where your application code hooks in to our protocol stacks, which we actually call soft devices, which is a generic term for all our protocol stacks, because we have the stack, and of course we have a management system around that stack, which is essential for expected behavior and for graceful behavior. So when you've developed something on, say, the 51.422 or the 51.822, you will see a common API when you come to this device. So you don't have to rewrite your application code. The APIs will be what you expect to see and what you've been familiar seeing on the other devices. So if we try and look at a few applications for this part, the thing with ultra-low power wireless is it really is as big as your imagination. I think we've all probably seen there's been so many projects on Kickstarter and all these various things, as well as the big usual names out there, making products in the ultra-low power wireless field. But it's almost every day there's some fairly radical and exciting new development, I would say more so than almost anywhere else in electronics. So it's a very, very broad field. If we look at Ant, for example, they've dominated the fitness market almost completely. I would say 90% and beyond of wireless sports fitness products that are out in the market are enabled with Ant. What they've done is because it's not an international standards organization, they've been able to work very, very quickly and address needs that customers have. So if we go back to thinking about the Ant Plus that I spoke about, as they hear customers saying, well, we need something like geocaching, or the cycling guys, they want some profiles, even smart home, clinical integration, if you can read that right-hand graphic, elderly care, they're able to put together profiles that are specific to certain application segments very, very quickly. So there's been a huge range of application profiles developed by Ant that make your life a lot easier when you're going to a particular market. And it also solidifies the market. It makes it a little bit more homogeneous, so people can look and see, okay, there's a profile, it addresses my needs, it's also what other people are using in the industry, so it sort of brings some cohesion to the industry. So Ant is very powerful in sports and fitness, always has been. Of course, there's an obvious use case with Bluetooth Low Energy also in that market now, because again, it's all about the mobile phone. We always have our mobile phones with us, so it's a UI device that you don't have to make as an application developer. You can fairly safely assume everybody has that UI device on them. So of course, the Bluetooth Low Energy appeals to almost any application for that very reason. But there's a fairly big crossover for a lot of application areas. So sports and fitness, healthcare and wellness, I would say, are very, very applicable to both of them. They have certain differing benefits in that. And I think domestic and commercial sensors is a big growing area, together with this Internet of Things, etc. That's slightly tied in with smart homes, smart factories, smart premises, etc. So I think it's important, before we get onto the 51922 as a device, that we just review what Ant can do and what Bluetooth Low Energy can do. Ant is present, as I say, in some mobile devices, so it is possible with certain mobile devices to connect straight up to an Ant network, but it isn't adopted across the board. So obviously that creates some challenges in certain situations, because you can't guarantee, if you're selling to the general market, that somebody has an Ant-enabled phone. But what Ant does have is a much more fully featured or a larger set of features in terms of the type of networks you can create. You can create point-to-point networks, you can create star networks, you can create trees, you can create practical meshes, there are shared clusters. There's a whole range of different network topologies. And as I'll point out when I talk about Bluetooth, Bluetooth is purely star or point-to-point. That's all you can do with Bluetooth Low Energy. That's fine for most use cases. But if we look at something like a smart home or a smart premises, then a star network at 2.4 gigahertz is really going to have certain limitations because, of course, of range. You're only going to get 10 to 15, 20 meters maybe. So within that sort of range, fine. But if you want to cover a shopping centre or a home, for example, then you really need to have multi-hop networks. There's no two ways about that. Of course, things like Zigbee have been out in the market for a long time, but I don't think anybody who understands this would truly say Zigbee was ultra-low power. Certainly, if you look at the numbers compared to ANT, they just speak for themselves. They're much, much lower. They're both 2.4 gigahertz, so physics is physics. For a certain amount of power, typically the radio signal will go as far as physics dictate there. So there are certain benefits you can get from certain processing techniques, but by and large, the frequency you're at and the power you're at will dictate how far your signal will go. So ANT has an awful lot of application possibilities, I think, outside of sports and outside of medical, where it's already been very strong, but within smart home and smart premises type applications. As I say, the performance is excellent. It's pretty much best in class. Nothing really beats it in terms of average power. It's very, very simple to use also. So this is another key feature. It's extremely simple to use. It's very, very straightforward for a developer to get a network up and running. Because it's been around for 8 years, it's very, very popular. So you can find lots of products in the market there with ANT on board, but also there's an awful lot of third-party design houses out in the world who are already making products, who already understand this technology very well. So as a lot of people on this call will know, in this day and age of globalization, often developing an application is not just a bunch of guys in a room. It's a collection of bunch of guys in rooms around the world, and often you need to work with partners to get certain parts of what you want to do done. And there's an awful lot of people out in the world who understand this and have skills in this. And it's been out in the market. We know it works, which sounds straightforward enough, but there are some other technologies out there that there's an awful lot of talk about, but there are question marks over, does it work? This stuff works. The products are out there. I guess Bluetooth Low Energy has become much more. It certainly had an awful lot of press, which we're very happy about, and it's gathering day by day by day. It's an integral part of all new smartphones. So I think everybody is interested in getting into the mobile sort of ecosystem if they can. So this really has brought the first true ultra-low power wireless technology into not smartphones, phones per se. Typically we've had Bluetooth and Wi-Fi, and neither of those technologies work from an ultra-low power point of view. They're fine on the phone, which has a very big battery, but when we're talking about sensors, which are typically battery run, and even more typically running off coin cell batteries, your average currents really need to be down into the order of, low double-digit microamps or below, really, to be able to have those batteries run for a year or more, which is typically what a customer expects. So another great aspect of Bluetooth Low Energy is the whole development of apps, which has sort of taken upon a life of its own. I think there's close to 1 million apps on the Apple Store. So again, app development has really changed everything. Before, maybe you had to make a UI device, Now you make an app, and lots of people are doing this now. You make an app to read back your sensor data, or maybe programmable logic controllers in factories. There's a whole range of things you can do now with the app framework. As I say, fundamentally different to ANT in terms of what it can do in networks. It's point-to-point and star, and a peripheral can only talk to one master at a time. ANT can have masters and slaves talking to different devices, so there's actually an awful lot more flexibility within ANT. It's a little bit more rigid here with Bluetooth Low Energy. Of course, Bluetooth Low Energy it's an IEEE standard, so it has that benefit. It's very, very rigorous, and it goes through all of the processes that you would expect with such a standard. But basically, as you see here, really what's happening is you can pick up all this sensor data up to the phone, and then either via cellular data or via Wi-Fi, it's up into the cloud, and then you can take it anywhere you want on the planet. So that's the obvious benefit of Bluetooth Low Energy. So having set the scene there, which I hope I have, we're on to the 51922, which is our device, which is what we're concentrating on today, which has both of those technologies inside. So, as I say, I compare and contrast them, but with this device, it really doesn't matter. You've got the best of both, so you can use each one for whatever it is best suited towards. So now that we know we have that technology on board, let's look at the device a bit more. Well, this is a very, very capable device in its own right. It isn't just an ultra-low power wireless connectivity part. You know, this has a 32-bit ARM Cortex M0 processor on board. So you've got some pretty serious computing power for the kind of applications that these sensors typically do. Because we've migrated to the ARM Cortex M series with the 51 series device, as I say, you can migrate your code across all of our devices. But maybe more importantly, ARM Cortex is a very, very popular processor core within the market. So using the CMSIS standard, which we've adhered to, it's also very straightforward to port code across from other ARM platforms in the M series across to our device. Or should you need the power of an M3, for example, porting code you developed on our devices across to a more powerful processor if you need to take that code and add to it and be on a more powerful platform. So again, the ability to migrate code across has been simplified here. In terms of the device, there's a full range of analog and digital peripherals you would expect. We've got 2x SPI master slaves. We've got all the digital interfaces you'd expect. 2-wire, UART, and SPI. There's a 10-bit ADC on board. There's also a quadrature demodulator in there, which can be used for encoders or the like. This is very, very suitable for the desktop market, which is a powerful market segment for us. So hence the inclusion of this peripheral there. But it does have other uses outside of being used for an optical mouse. As I say, for rotation control and speed control, it can be used for that also. We introduced something called the PPI, which is the Programmable Peripheral Interconnect on this family of devices. These features are common to the 51822 and the 51422, by the way. It's a common hardware platform. So the beauty of the PPI is this is a bus where all the peripherals can talk to each other autonomously without the CPU being involved at all. And they have a task and event system, so they can be triggered and they can carry out a task and they can create events for other peripherals. And they have, each peripheral has its own associated memories. So it's almost like a little autonomous machine, each peripheral in its own right. So to give you an example, you could be sampling ADCs, you could be making ADC samples, you could be triggering radio broadcasts with no intervention by the CPU. Of course, CPU would come into play when the protocol kicks in, but any of the other tasks that you're doing around that, you do not need the CPU involved. So there's a whole range of scenarios where you can just have peripherals triggering each other with their tasks and events, carrying out functions, and you're not having to consume the current of the processor core. There's full encryption engines on there, so you've got AES, ECB, CCM, AAR coprocessor on board, which covers pretty much all the encryption requirements that are needed at this level. It's got a range of oscillator options. You do require a crystal oscillator to run the radio because of the sort of tolerances that the radio requires to operate. But there are RC oscillators on board also at 32 kilohertz and 16 megahertz. So you can close down the crystal oscillator if you want to run the processor on an RC oscillator, for example, if you're doing a lot of processing on something and you don't want the current consumption of the crystal oscillator. There's a full range of timers, 2 16-bit, 124, and 2 times 24-bit real-time clocks. A range of power supply options. You have LDO, LDO bypass. Obviously, you can hook up the device to a direct 1.8 supply if that's available elsewhere on the board. You have a linear regulator and a buck DC-DC converter, which can improve efficiency considerably down to 2.1 volts, after which you would switch to the linear regulator. The DC-DC will not operate below 2.1. The software stack, as I say, we've been calling our software stacks soft devices. This one is designated the S310. It's pre-programmed, as I say, containing ANT and Bluetooth Low Energy and the whole management system around that. So you tie into make API calls to the S310, and that's how you work with the protocols. It's currently in a 6x6mm 48-pin QFN package. So further down the line, there will be wafer level chip scale parts also, but currently it's 6x6 QFN package. So the S310, if we quickly look at the stack itself, just to try and graphically show this to you. The BLE profiles and services are separate from the ANT profiles and services, of course. We have the SVC APIs under there, which relate to the ARM platform, and then they are essentially side by side. There's no common elements apart from the actual radio and the silicon level. So if you want to call, or as I say, calls you would have been using on our previous Bluetooth Low Energy device or our previous ANT device, you call them with the same API calls as you would have seen previously. As I say, it's full peripheral stack for Bluetooth Low Energy, full 8-channel ANT stack. I think also when the APIs that we've made for the Bluetooth Low Energy side, for example, you've got all the full access to GATT and GAP. So you can create your own profiles by selection of services and defining your own characteristics, which has been done actually. You can find on our website, we've introduced nRF UART, which is a UART over Bluetooth Low Energy. Now there's no profile under the Bluetooth specification currently for a low energy UART, but we saw a need for it, and with the access to GATT and GAP, you can do the same. You can create your own profiles as well as use the profiles out there. Also, we give access directly to what's called the L2 cap layer. Without going into a lot of detail, when you hear about things about Internet of Things and this sort of thing, which is essentially IP addressing, or probably going to be essential to have IP addresses out to every node. That would necessitate being able to talk, pretty much necessitate talking to the L2 cap layer. So we have API calls so you can talk to that layer as and when these standards are ratified or they appear on the market. They're not there yet, but this device can go forward and be compatible for those standards. Yeah, as I say, full concurrent BLE operation. A key thing about the way the software stacks and the application work in this device is they're entirely separate. So if you look on, and this applies to all the 51 series devices, they live in entirely separate parts of memory. You compile your stack, it doesn't. You compile your application, it has no bearing on the stack. The stack will always have the same areas in memory. It will always use the same resources in RAM. It will always use the same peripherals in a known way. Now, if you typically work with the only company doing that, I must point out, if you build everything into a singular framework, then anyone who's worked as a software developer will know that each time you compile everything, lots of variables and lots of things go to different parts of memory. That's just what happens. So when you're trying to track bugs and events and little anomalies, that can be very, very hard because every time you compile, things can get shifted around. You don't have as many known datum points. What I've had great feedback actually with these parts from developers on this is when you're making your application, you compile, you don't even think about the stack. You don't need to worry about that. It has a known set of resources, it has known behavior, and it will not move around in relation to your application. So you would just debug and develop your application as you would without using a radio or a protocol. So this is a very powerful development paradigm, I think, and makes development much, much easier. The key features of the soft device, well, it's Bluetooth Low Energy compatible with all that you would expect, GAT, etc. Full ANT, ANT+, it's pre-programmed and has a number of features. I don't have enough time to go through all of it, but it also has what's known as a file share feature, so you can do burst transfers with ANT. If you're doing some data logging of something, you can burst transfer all the data you've been logging over a period of time, and that's at a higher speed than normal at 60 kilobits per second. The S310 currently is taking approximately 128K of the 256 kilobytes of flash that are available. There's 256 kilobytes of flash available in the part with 16K of RAM. So you still have 128K of application memory available to you, which is a considerable amount, again, for sensor type applications. One thing I think I just wanted to point out to you, because a lot of people, I guess, would have the obvious question of what about if ANT and Bluetooth Low Energy want to start doing things at the same time? What do we do about contention? Well, this has been baked in to the 310 soft device. This is integral. You don't set priorities in the application. So, we've got a lot of experience of this, and there are certain known scenarios, and this is actually built in down at the link layer. So when there are contentions, there's a mechanism to handle that. It isn't something you have to think about at the application layer. Now, obviously, there are a number of scenarios, but just to try and show you here what typically happens, if you've got a straight conflict and Bluetooth Low Energy and ANT are at approximately the same time interval in terms of their connection events, the ANT or the Bluetooth stack will ahead of time request the radio. So ahead of time it says, I want the radio at a particular time. There are no predefined time slots in this system. So they basically just request time as they need it, it's a first come first serve system. So if you look at the top diagram there, if Bluetooth Low Energy has got there just first, what it does is it holds on to the ANT request. As soon as Bluetooth Low Energy is finished, it gives access to the radio to ANT, and ANT will do its communication. Exactly the opposite is true. If ANT had got there just first, it would finish, and then Bluetooth Low Energy would take place. But there's a lot of intelligence built in here also. What it also knows is, for example, if Bluetooth Low Energy has a more frequent connection event time than ANT, it will take that into account, and should it be in the middle of a number of connection events happening with Bluetooth Low Energy, it realizes, well, ANT is maybe transmitting every 500 milliseconds. So, we need to actually get this connection event in now. So what it will do is, if there's a fair amount of traffic happening with one of the protocols and the other one is requesting some attention, it will squeeze that in and then go back to finishing what it was doing with the other protocol. But as I say, I think the key thing here is this priority system has been baked in. It's an integral part of the 310. You don't have to think about prioritizing things in the application. It is taken care of. So in terms of tool chain, well, we have an SDK, a common SDK for the 51 series. So we have examples for Bluetooth Low Energy and for ANT. I will say we only released this device yesterday, so we're still working on SDK examples 51922. But of course, it's not a huge amount of work to rework or adapt anything from the existing SDK to this part. We do have one example which I will cover coming up now. So, we're always updating the software development kit with the examples. It's optimized for the Kyle MDK ARM toolchain, but we also have support on IAR embedded workbench, and we also have support within the SDK for GCC and Eclipse. So briefly on the profiles, I'll skip through these. There's a number of profiles available, just to show that these are all supported. We may not have an example for all of them. We do have an example for an awful lot of these, but the soft device can support them. So I'm sure you can look at this probably at your leisure. I'm sure it'll be available afterwards. But all of these profiles you can see for Bluetooth Low Energy. There's a whole range: hit over gap, heart rate, proximity, thermometer, etc. You can see they're all the current profiles. Our soft device and our protocol stack can support them. So I think it's important just to look at the connection topologies that would happen with the 51922. I think I've got 3 here, or 4. The first one is a straight bridge. If you look at the color coding there, you can see the red device will be an ANT device. The blue circle there is the Bluetooth Low Energy on a smartphone or a tablet. So that could be a heart rate monitor, it could be a cadence sensor, it could be a light control, it could be a humidity sensor. It's already in the market, but you would like to have some cell phone connectivity. With the 51922, you can make a bridge device to bridge cell phones to existing products that have ANT in the market. The other type is essentially a connectivity gateway. So this is a little bit more smart home related. You would have all these ANT products in the market that could be talking on a mesh, and then you could either have these as a gateway alone, the 51922, but probably more, you would have them operating within that ANT network, and they can gateway to another mobile device as frequently as you want. You may just have one gateway, you may have a few around the network. And this is really just to show that even if it's acting as a gateway, it can operate as a hub for all these ANT devices. It does have full 8-channel ANT capability. So if you imagine that mobile phone here, this maybe could be, say, a cyclist, and there could be a cadence sensor, heart rate sensor, power sensor, etc., etc. And this may be a smartphone gathering all that data and displaying it. So it's periodically updating. Another scenario is you could just have this ANT network with a 51922 gathering ANT data, and then at a later date, this might be in a smart home or in a factory or a shop. At a later date, you come along and introduce the Bluetooth Low Energy mobile device to the network and do a data download. So the 51922 has the power to be a data logger. You know, there's plenty of memory there. You've got a powerful processor. It doesn't just have to relay data. It's a powerful system on chip in its own right. Power consumption. To cover this, I've made this slide very, very simple because people probably want to know, are there any hidden nasties or gremlins in there? No. I could spend 3 hours talking about various power consumption scenarios, but if you add up what you expect your average BLE current consumption to be in a straight BLE scenario, add up your ANT, and then whatever the average current application current consumption is, that will be your average current consumption. So the key thing there is there's no hidden processing because you're running two stacks. It is just whatever you do on one, whatever you do on the other. Of course, whatever you do the application, that is your total. There's nothing hidden in there. The demo I spoke to you about, which we have on the web, is actually a heart rate relay demo that runs on our evaluation kits. But this could be adapted to any ANT to low energy relay application. We've just happened to implement the heart rate monitor to display this. So this is available on our website if you wanted to use it. We've just released this to part yesterday. We're at engineering release, so parts, development tools are available. Going forward in some months, we will do full production release, but all documentation is available. So should you wish to start developing, we have a development module here that it interfaces to our nRF Go platform. So you need the nRF Go platform, but if you have that, you can plug this in. It's got an SMA connector. You can do everything you want, and you can even take detailed RF measurements should you wish to because of the SMA. So I'll summarise now. I think we've got about 7 minutes left. Just to reiterate what I've said, the key word here is concurrent. The 51922 can run ANT and Bluetooth Low Energy at the same time, and it's an SoC. So it's not just connectivity. This can actually do lots and lots of work, this device. It's a full Bluetooth Low Energy peripheral device, full 8-channel ANT device. It's pin compatible with all the other 51 series devices. So same board for everything, same PCBs, same bill of material. It's a pre-programmed device, so it's in the part. And we have engineering releases available now. So if you want to get hold of parts, you want to get hold of boards, we have those available. So that's my presentation finished. I hope it was informative. We're very excited about it. I think it's a really, really exciting and cool part. And now I'm ready to field your questions.
Yeah, hello everyone. I said you all unmuted, and you can, if you have questions, don't hesitate to ask John.
So thank you for your talk. I have a question whether you might produce a version with a little more RAM.
It's definitely on the drawing board. We want a bit more RAM in there. I can't give you a categorical date, but I can tell you that that's very, very high up on our priority list. But
okay,
yeah.
Maybe then another question is an update to the S310 software stack planned, or how would it be done?
Well, you mean a next revision of the stack?
Yes.
Yeah. Well. Yeah. I mean, currently, obviously, we do a lot of testing and performance tests with the stack before we put it onto the chip. I would say when we release the production part, yes, that there will of course be improvements. Code will be even more optimized. So protocol stacks there's always something you can make a little bit better. So yes, I think you will see a newer revision of the S310 soft device when we come to production.
Fine, thank you.
Hey, John, from my side, so I just see there is development kit for 51922, so there will be no evolution kit for these chips.
Yes, there will. But as I say, we've just released yesterday. This is at engineering level. So I would also say, as I'm sure probably most people on the call know, you don't go to production with engineering samples. But of course, in the next 3 months or so, we'll go to production. So when we go to production, we'll have full development kits, full evaluation kits, everything you would normally expect. It's just because this is engineering release, so there won't be evaluation kits for engineering release.
Thank you. Hello, everyone. Did anyone have further questions?
Not yet.
Okay, thank you, John.
You're welcome.
Thank you for the great presentation for today.
Thank you so much for coming. I really appreciate it.
Can I send your presentation to our attendees?
Yes, of course.
Yeah, I will send or a mail for today's presentation. And now I think thank everyone for the presentations. And now I think we finished this today.
Okay, thank you.
Thank you.
Thank you.
Yeah.
Bye bye.
Bye bye.